Good afternoon, then. Laura Garcia, Nicole Mendez, and whoever speaks to you, Carolina Ramirez. We will discuss the issue of industrial dryers. Next, please. We will start by defining what drying refers to, which is basically the removal of water in relatively small amounts from processed materials and other substances. The term drying is also used in reference to the removal of other organic liquids, such as benzene or organic solvents from solid materials. Drying is often confused with evaporation. Drying is the removal of water in small amounts, while evaporation is the removal of water in large amounts from materials. Next, please. For sizing the use of drying equipment, it is necessary to take into account the concepts of humidity, dew point, which is the temperature at which the mixture between air and water vapor is saturated with water, humid heat, humid volume, well, among others. We see in the graph also other humidity parameters. When a solid of a certain humidity comes into contact with a current of air with a center humidity and temperature, it is a process that generally uses a large excess of air, so the condition of the latter remain unchanged. With enough time, the solid has lost so much water that there comes a time when the humidity of the solid also remains constant. This measure value is known as the equilibrium measure. In turn, this value depends on the type of drying, whether it is by desorption or by absorption. The free moisture content of a sample is the moisture that is above the equilibrium moisture content and can be removed by drying. Next, please. For example, we find in a humidity graph for mixture of air and water vapor, like the one we see here, that if you have a material with a humidity of 10 kilograms of water per 100 kilograms of dry material, horizontal line, in contact with air at 25 degrees vertical line, which has 50% of relative humidity. Next, please. Now, if we say that the material is, for example, silk, we locate it in the following graph that shows typical equilibrium moisture content for some solids at approximately 25 degrees. Number 4, we can see that it can only be carried up to one humidity of 8.5 kilograms of water per 100 kilograms of dry material. Below this point, the sea cannot dry as it is the minimum moisture content it can have. Next, please. In addition to all this, to size the equipment for drying, it is necessary to experimentally obtain drying curves of the material with which it is going to work. This is basically done by measuring the weight of a small sample over time as it dries. In the graph, it can be seen how the free humidity, which is the available one, decreases with time until reaching zero. Next, please. Okay, the following figure shows the drying speed curve for constant drying conditions. Drying begins at A. At the beginning, the solid tends to be at a lower temperature than it will have at the end, and its evaporation rate is increasing. Upon reaching point B, the surface temperature reaches its equilibrium value, and therefore we have a constant velocity between B and C. If the solid is hot enough to start, the drying speed can be started at A with quotation mark. In the drying of some materials, the CD regions don't exist, or it constitutes the entire period of decreasing speeds. This decrease is a critical period because the characteristics of the material depend on it. Points in the figure correspond to the critical free moisture content, and it's known that in this situation there is not enough water of the surface of the solid to maintain a continuous film of water. At point D, the surface is completely dry. It's possible that the amount of moisture that is removed during the decreasing rate period is very small, but the time for this can be very long. It already depends on how dry the material is wanted. Next, please.
We are going to talk about dryers. They are equipment mainly used to reduce or completely eliminate humidity from the final product. And in these equipments, the heat source is a stream of hot gas. Next, please. Okay, so the material for drying can be static, mobile, fluidized, or dilute. When the material is static, there is no relative motion between the particles. When the material is mobile, there is a slightly restricted bed of solids in which the particles are separated just enough to flow or slide over each other. Normally, the flow is drawn inward by the action of gravity. When the material is fluid-side, the solid particles are held by means of drag force caused by the gas phases that passes through the interstices of the particles with a given critical speed. And when the material is dilute, it is in a condition of total expansion in which the solid particles are so separate from each other that they have particle no influence on each other. Next, please. Okay, so the hot gas flow can be parallel. The gas flow direction is parallel to the solid phase surface. In perpendicular flow, the direction of the gas flow is normal at the interface of the phases of the gas. When it's co-current, the gas phase and the solid particles move in the same direction, and when it's co-current, counterflow, the gas phase and the solid particles move in opposite direction. In direct circulation, the gas penetrates and flows directly through the interstices of the solids, circulating in a free way. And when it's crossed, the direction of the gas flow is carried out at right angles in relation to the movement of the solids. And next, please. Okay, so the basic configuration of a dryer must have an air generator system, a heater, and a feeder. The air generator system allows air to enter at different flow rates. Electrical resistance are used together with a serial of nickel and chrome to generate heat. Dryers must have a heater. In indirect dryers, the air is heated with combined with gases, and in indirect ones, the air is heated through an electrical resistance plates. And it must have a feeder, and the most common feeder used are screw or rotatory tables and trays. In some cases, a special feeder has to be used to ensure uniform anticipation of the feed. Next.
Dryers can be classified by the method of heat transfer to wet solids, such as direct dryers, indirect dryers, and miscellaneous dryers, or by handling characters and physical properties of wet materials, such as bath dryers, continuous dryers, dryers for granular or rigid solids and semi-solid pastes, and dryers that can accept liquid feeds or suspensions. The first sorting method reveals difference in dryer design and operation, while the second is more useful for selection from a group of dryers undergoing preliminary consideration regarding a specific drying problem. First, we will talk about direct dryers, where the dryer is by convection. The heat is transferred to the solid that is being dried, a stream of hot air, the humid air, or an indoor gas that, in addition to transmitted to heat necessary for the evaporation of water. It is also the transported agent for the water vapor that is removed from the solid. Drying gas at temperatures can range from 15 to 400 Celsius depending on the material. The type of gas stream is selected depending on the material to be dried. For materials that are highly sensitive to heat may recruit the dehumidified air and to dry explosive or flammable solids, or wet and organic solvent must be removed and inert gas might be necessary, like nitrogen. The general operation character of these dryers are direct contact between hot gases and solids used to heat and separate the steam. There are limited bath temperatures of 1000 Kelvin because it is the one that can withstand almost all structural materials. The efficiency of the equipment is directly proportional to the mass flow of the inlet gas. Therefore, if the same temperature is maintained and the gas mass flow increases, the efficiency will be higher. The amount of gas required to prop the drying head depends on the gas inlet temperature, the drying temperature, and the amount of material to be dried. These types of dryer can be continuous, where the operation is without interruptions as long as the wet is supplied, or innovation, we shall decide to operate with a specific wet feedback size for given cycles of time. The operation cost of continuous direct dryers is lower, and direct bath dryers are used for low production capacities and for the treatment of products that require special handling. Among the types of direct dryers, there is dry dryers. Material which can be a lumpy sort of paste is sprayable or a metal pen 10 to 100 millimeters deep. The thermal performance of this type of dryer are usually between 20 and 15% and may be lower. Tray dryers are usually for drying small lots of various products. In general, they are sprayed when the necessary capacity does not exceed 25 to 50 kilograms per hour of dry product. Operation: a fan recycles the steam heat are in parallel of the surface of the trays. Electrical heat can also be used, especially when the heat is low, more or less 10 to 20% of the air that passes over the trays is new, and the rest is recirculated air. It is advisable to have an air circulation with a speed of 1 to 10 meters per second to improve the health pockets. Most air is continuous evacuated through the outlet duct and fresh air enters through the inlet opening. At the end of the drying cycle, the trays are removed from the chamber to proceed with the unloading of the dry product and will replace by others for a new lot. Rotatory dryers are really used for the drying of granulation material of powders, since their advantages are great if we compare them with other types of dryers. They are flexible, very versatile, and very especially suited for high production rate demands. On the downside, they are typically less efficient, require high capital costs, and significant maintenance costs depending on the material being dried. They are not recommended for brittle materials and for low production rates. Operation: the drying consists of a drum that rotates on the central axis to which the material to be dried circulates. Normally, they have a slight inclination in relation to the horizontal. Inside the drum, a step of heavy air is introduced which will simultaneously be the heat transmission medium and the vehicle for the transport of material or concurrent. The low mode is present when the material is not heat preferred for heat-sensitive materials and for high drying rates in general. The solids are introduced at one end and move along it due the rotation, the effect of the load, and the slope of the cylinder. They are discharged, and the other end is a finished product. Tunnel dryers are very common in food dehydration. They can be configured in parallel and against the current, the first being the soft test for the product wheel, in the second the contact the warmer air with the dry product favors the hardening of its surface. They can reach up to 24 meters in length and consist of a cabin in which there is a rail mechanics that move gears with product along operation. The wet product is spread in uniform layers of trays. We are taken in trolleys, leaving a space between the trays for the drying air to pass through. The loader trucks are introduced one at a time of suitable intervals in the tunnel. A full barrel is introduced through the wet end of the tunnel. Another one of dry product is removed through the dry end. The air is moved by fans that make it flow through them. Normally air velocities between 2.5 to 6 meters per second are used. Spray dryers. In this type of dryers, the materials must be automated and distributed under controlled conditions. Drying time is direct relation to particle size. Different types of material can be handled, ranging from suspension solutions to pads and even hose. It has very short times, from 1 to 20 seconds. The drops usually have diameters of 10 to 30 micrometers, and therefore they offer a very large surface and per unit volume to air, which results in drying process very fast. Operation: the product is sprayed in a hot gas stream to obtain a shower of dry droplets. The water evaporates from side droplets quickly, and the dry solid arrive from the gas stream. Both gas and liquid spray chamber can be connected in parallel or a combination of both. It is necessary to ensure that wet droplets or particles don't cool or adhere to solid surface before they have dried. Therefore, with large cameras are used. The dry solids exit the bottom of the chamber tube as gray convert and exhaust gases flow into a cyclone separator to filter the very fine particles. Fluid bed dryers is a widely used product within the pharmaceutical industry due to the high efficiency to dry the granules obtained by wet granulation. Drying of the granules is carried out by the combination of the diffuse of moisture from the solid mediated by hot air, and the retention of this moisture by forced convection. In this unit operation, the granules must be uniformly fluidized by hot air are designed so that efficient to the transfer mass and energy take place. Operation: the suspended material is continuously fed to the bed chamber, which is filled with ceramic surface with a diameter of 1 and 3 millimeters. As soon as a material is introduced into the chamber, it is rapidly dried by the combination of conduction heat from the heated ceramic surface and by the convection heat of the hot freezing air. The fat material will adhere to the ceramic surface that flow into the fluidized bed and will instantly become dry. During the flow of the ceramic surface is fluidized by the collision with each other. Separation the dry products from the surface of this. As the product dries, it becomes lighter and is allowed to carry the fluidized air, and the discharge the dust collection or bag flicks the box. This process guarantees a fine pocket-like final product with particular size close to its primary and extremely low moisture content.
Well, if we talk about indirect or conduction dryers, they are characterized in that in them the transmission of heat to the wet material takes place by conduction through a wall, generally metallic. Since there is no gas flow on the wet solid side, it is necessary to apply a vacuum or use a gentle gas flow to remove the, the moisture. Indirect dryers allow the recovery of the solvent and are suitable for drying at reduced pressures and in inert atmospheres, which makes them recommended for the dehydration thermally or easily oxidizable products, being able to use drying methods to ensure better height transfer and eliminate heat buildup, moisture grains in the product. Next, please. Okay, the first type is the drum dryer. This type of dryer allows high drying speeds and economy in the use of heat. However, this type can only be applied to liquid substances or in the form of slur capable of withstanding relative high temperatures for short times from 2 to 30 seconds. 4K variables influence the performance of the drum dryer. They are vapor pressure or temperature of the heating medium, rotation speed, film thickness, and feed properties like concentration and temperature. Next, please. Okay, in this type of dryers, a rotating metal drum, internally heated with heat, is immersed in tank containing the substance to be dried. A thin film of the substance is retained on the surface of the drum, and the thickness of the film is regulated by a dispensing knife. As the drum rotates, moisture evaporates into the surrounding air by heat transferred through the metal in the drum. The dry material is continuously dashed from the drum surface by means of a knife and collected in the form of flakes. For a dryer of this type, the factor that controls the drying process in the transfer of heat, since the liquid is initially heated towards its boiling point, and then the moisture is released by boiling at constant temperature. Next, please. Vacuum operation of single and double drum dryers is done commercially to improve drying speeds of heat-sensitive materials. They are also used when a porous structure of the product is desired, and it should be clarified that when the recovery of solvent is a problem, once again, the vacuum operation is recommended. Next, please. The second type is screw type driver. It consists of a horizontal screw conveyor confined within a jagged cylindrical casing and is recommended for difficult to handle materials. It is often selected before other dryers with conveying mechanisms as it provides an uniform flow in addition to an environmentally clean operation, allows solvent recovery and avoid dust contamination. Next, please. Okay, feed entering on one end is slowly transported through the hot sun and discarded at the other end. The steam here is straight through pipes placed in the upper part of the casing. It is 8 to 65 centimeters diameter up to 7 meters long. In addition, it has deflectors placed on the discs themselves and on the drum, which have the dual mission of moving the product forward and preventing it from sticking to the walls. A screw conveyor drives treat solids that are too thin and too thick to operate with a rotary dryer. They are closer together and allow solvents vapors to be recovered with little or no dilution with air. Next, please. Okay, the third type are vacuum dryers with shelves or trays. These dryers are indirectly hard and are batch type, similar to tray dryers. This class of dryers consists of a cabinet constructed of cast iron or steel plate with hermetic doors in such a way that it can be operated under vacuum. The hollow steel shelves are mounted inside the chambers and connected in parallel with the inlet and outlet stream manifolds. The trays containing the wet solids are placed on the whole shelves. Heat is conducted through metals, walls, and by radiation between shelves. For operation at lower temperatures, hot water circulation is used instead of steam to supply the heat that vaporizes the moisture. The vapors are collected in a condenser. These dryers are used to dry expensive or temperature-sensitive materials or that rust easily. They are very useful for handling materials with toxic or valuable solvents. Next, please.
Okay, so the other classification of dryers are special dryers. They are used in chemical industries, perhaps less frequently than the types discussed above. The dryers mentioned here make them more efficient or desirable for a given application. First, we have the two-stage dryers. The fundamental advantage of this type of dryer is that the moisture can be removed in the first stage quickly, using the appropriate conditions, for example, higher temperature or higher gas speeds, and use lower dryer condition in the second stage. Additionally, it provides cost benefits, energy saving, and efficiency and product quality. The black and white image shows a continuous fluid side bed that can divide in two zones, where the upper stage is a well-mixed fluid side bed for a product that is difficult to dry. In this stage, the internal heated panels are used to increase the drying speed, and the lower stage receives the output of the first stage by gravity through a discharge tube located in the center of the dryer. This is also a spiral fluid side bed, which controls the residence times of the particles to produce a better quality of drying. And next. Second, we have the flash dryers. These flash dryers can be used to heat sensitive solids in a view of a short time of exposure of the drying medium. They are inexpensive, although in some cases auxiliary equipment can cost much more than the tube basic itself. There is a risk of fire and explosion, so care must be taken to avoid flammability limits in the dryer. The operation, so in the color image, we can see the wet feed mechanically dispersed thanks to the impact of energy generated by the motor. The particles are in size of 10 to 5,000 microns. A controlled hot gas stream from the air is heated by the extraction fan through the main body and fluidifies the fine particles in the chamber. This ensures an optimal heat exchange and instant humidity evaporation. The dry particles are transported with the gas stream to the top of the dryer, where a separator classifies them according to their weight. Those that are too large or too wet returns to the lower parts, and those particles that pass the classifier are transported with the extracted air to a dust air separator system such as a clone. Next. Okay, so we have the belt dryers. They are a good choice for relative free-flowing products that can suffer mechanical damage if scattered. These dryers are quite versatile and can handle a large and arbitrary shaped particles that can be heated, sensitive, with bright at the same time. Gas cleaning and power requirements are minimal as low gas velocities and pressure drops are lower. From its design, it is important to ensure an uniform distribution of both of the product on the belt and the airflow within the dry chamber to achieve an uniform humidity content of the product. Clearly, this type of dryer is not a good choice for a very wet or very fine solids, and the residence times is between 10 to 60 minutes approximately. Next. In the video, we can see how it works. It is mainly a dryer in which the belt is a perforated belt on which the bed of wet solids enter from one side of the dryer. The hot air at low speeds flows upwards throughout the belt and by the means of the fans move along the chamber to achieve the drying. On the other side, the product comes out dry and free of humidity. And the last one are the infrared dryers. These dryers depend on the transfer of radiant energy to evaporate humidity. This energy is supplied electrically by infrared lamps, electric resistance, or incandescent gas heater refractories. The wave will carry the energy with them, and when impacting the surface of the object, will deposit a large part of their energy on it, generating heat and the physical body. Infrared dryers can produce much higher levels of heat flux, that is 4 to 12 kilowatts, than the other dryers. However, in many dry operations, a high heat energy is not required. There are some specific applications to this type of dryers in certain industries, for example, in the drying of coated paper. These dryers offers the advantage of compactness, simplicity, and low equipment cost. And additionally, they offer a potential for significant energy saving and improved drying speeds with a better quality of the product. Next. Okay, so industrial dryers are an essential part of the material processing, but they are generally a large capital expense and can last decades. This makes choosing the best dryer is very important. The starting point should be to observe the size and density to the individual particles within the material being drying. A fine powder will require a different drying method than a material at the same size as a mud. Second, although it seems very obvious, it is commonly overlooked. The initial and final humidity percentage must be known, then it's used to size the dryer. Some materials react to heat once it reaches a certain temperature. In some products, it can cause a chemical reaction. In others, they can melt or burn if they reach a certain temperature. Next, please. Okay, and it is important to think about how material is handled, both wet and dry. You can use a non-stick surface and buoy pallets to keep material flowing as needed. Cleaning accessories can also be important to incorporate to keep the system clean and remove any potential that is not desired. And it's important also to make sure that the dryer is correctly sizing for the expected production quantities. If the dryer is undersized, it will suffer from adverse conditions, causing the product not to dry properly and suffer other quality control problems. And finally, an important part, of course, is the cost. The initial capital expense of the purchase of the cost operating over its useful life. Some options may be less expensive, but they work less efficiently and their cost can be higher than a more expensive but efficient dryer. Next.
Dryers are used in industries such as paper, food, textile, chemical, cement, and construction materials for various products. In this video, it is possible to observe a drying system consisting of a series of steam heated cylinders over which the sheet of paper or fabric passes. The cylinders are arranged in such a way that they first contact one side of the object and the other to ensure its homogeneous dehydration. In general, the dryers rotate to the use of gears. The hollow rollers are internationally by steam. The head is transferred to the wall of the roller to the surface, which by twisting the paper or fabric will increase the temperature and they eliminate almost all the work. The paper or fabric will surround pairs of edge and every on the drying cylinders that make up the drying system. These drying systems are usually used in the paper and textile industry.
To finish, we will see some rules that are the responsibility of drying equipment. Next, please. The rule ISO 7183 from 2007 specifies the performance data that are necessary to establish and the applicable test methods for different types of compressed air dryers. It is applicable to compressed air dryers working with an effective of more than 50 kilopascals, but less than or equal to 1,600 kilopascals and include the following: absorption dryers, dry membrane refrigeration dryers, including shell drying, or a combination of these. A description of the operating principle of dryers within the scope of the standard is provided. Next, please. The rule EN 602-041 from 2006. The requirements affect the design of the electrical part of the machine and the interconnection with the low voltage electrical installation. In addition, it imposes testing requirements and necessary documentation to be delivered with the machine. Here we find a diagram where the content of the document is explained by sections covering all operating environments, emergency systems, operator station, engines, and other important parameters. Next, please. The Electromagnetic Compatibility Directive. It is the harmonization of the laws of the member states in the matter of electromagnetic compatibility of the device that can be placed on the market. It concerns each finished device or combination of finished device made available on the market as a single functional unit. intended for the end user and capable of generating electromagnetic disturbance, or whose operation may be affected by such disturbance. The directive involves the particular combination of various types of apparatus and possibly other devices, which are assembled, installed, and intended for permanent use in a predefined site. Next, please. Okay, the EHEDG facilitates safe food production by providing criteria as an authority on hygienic engineering and design. The main objective of this norm is the promotion of food safety through the improvement of hygienic design and engineering in all aspects of food processing. It requires that the handling, preparation, processing, and baking of food be carried out hygienic with measuring and handling conditions. And 3A standards. It is a globally recognized sanitary standards issued by 3A Sanitary Standards Inc. It is dedicated to advancing the standards of hygienic equipment for the food, beverage, dairy, and pharmaceutical industries, ensuring consumer food safety and public health. Surfacing contact with the product must have number 4, surface finish and be free of imperfections such as pits, deformation, and cracks. All onion surface, valves, pipes, and equipment in contact with the product must be easily cleanable. Their inspection must be quick. They must be they must meet the requirement of being easily removable. And next, please. And the GMP, they are applicable to the manufacturing operation of medicines, cosmetics, medical products, food, and drugs in their final forms of sale to the public, including large-scale processing hospitals and the preparation of supplies for the use of clinical trials for that matter of medication. They are included within the concept of quality assurance and constitute the factor that ensures that the products are manufactured in a uniform and controlled manner in accordance with the appropriate quality standards for the intended use of the products and in accordance with the conditions required for marketing. Next, please. ASME standards, American Society of Mechanical Engineers, Global Use Engineering Standards. It is an association of professionals founded in 1808 with the idea of generating a series of design codes for the construction, testing, and inspection of industrial capital goods, serves as a means to meet public safety, health, or environmental objectives within its jurisdictional boundaries. ASME standards have long served as a medium for technology transfer, allowing companies of all sizes to compete primarily as equals in an international marketplace. Okay, that's all. Thanks for your attention.